Everybody, happy Monday. I hope you're having a fabulous day, fabulous start to the week. Welcome to INE Live. I am your host, Catherine Brown, and we have an awesome stream today. We are super excited about this one. We've been working for a couple weeks to get this one off the ground, and we are super psyched to have our CEO, Richard McLean, here with us today. We're going all retro, all day. Richard is going to be showing us how to build a credit card size tap to play arcade machine using Raspberry Pi, Python, and NFC. So this is going to be a really cool stream. The best part of all this is at the end of the stream, we are giving it away to one of you. So we're going to post a link on socials right now. I think that link has already been posted. We'll drop it a few more times during this stream, but just click the link, submit your name. And before our stream ends, we will pick a name at random and send you this little tiny arcade thing that Richard's building today. So quick note, we are limiting shipping to the US. So if you're international, try to find an address in the US and we'll send it to you. So we are going to limit it to the US. But a little bit of housekeeping. As we do each time we stream here on INE Live, I want to let you know that we are streaming live right now across social media platforms, including Facebook, YouTube, Twitter, Twitch, and LinkedIn. Be sure to like and subscribe on the social media platform you're using so you can stay in the loop when we go live. And of course, stay in the know when we do these awesome giveaways. We want you to get involved, talk to us, talk to others. We are watching chat right now, see a ton of people on there, see some people who are our regular viewers here at INE Live, and see a lot of new faces as well. So I'm super, super excited about that. Raphael, do we offer Cisco packet tracer tutorials? The answer to that is yes. And we'll tell you how to find that on our socials. We'll drop a comment on there. But yeah, loving all the comments that we've got going on. Bob, I've been waiting all week for INE. Woo! Us too, Bob. All right. So with that, I am going to bring in our guest of honor today, Richard McLean. Richard, so excited to have you here.
Yeah, it's the INE Live that almost didn't happen, right? I think it's been rescheduled a few times, and those were all my fault. For one was a corrupted memory card, and the other one, well, we won't get into but some technical details arose last minute, so we apologize for that. But hopefully today, fingers crossed, everything will go smoothly as planned. And if not, it's not because of a lack of practice.
Happens to the best. We thought about putting last week's show on anyway because we were all prepped and ready for it. And with about 15 minutes to go, couldn't get it all together. And we thought, well, maybe we'll just do it anyway. And we decided not to because Richard was just getting too frustrated.
Do it live, sometime. But
so we're gonna do it. We're gonna do it up well this time.
Excited to be here, and this is more my passion projects on the side. I'm really big into retro gaming. My wall on this side that you can't see is lined with consoles from my childhood, and most of them are the consoles I had when I was a child. So that's exciting. But it's a little bit cumbersome to use I actually use a SCART switch box with a RetroTink 5X, if anybody knows what that is. But it's it's very complicated to get your family and your kids to jump down and be able to just pick up and play a game. And also, you look through this library of all these different games and stuff. And I think the inspiration for this, if I can share my screen, I just wanted to give this guy some credit as well. The inspiration for this was this tweet I saw long ago. I think it was 2018. And he built a jukebox using cards, and you can click play here. But it's a swipe to play jukebox, like The Sound of Silence, and it just plays. It's using swipe card instead of NFC, but and it just plays a song that you select. I was like, this is a great way to bring back, that physical feeling. I can find my camera here. That physical feeling of holding something and being able to interact with a device. And I just really love that aspect about it. And, I just had all these components and I was like, let's try this out and see if we can get something to work.
All right.
Fingers crossed. It works. We'll see. But.
Hey, for those who may be joining us who are not super familiar with Raspberry Pi and not with Python, can you just kind of start ground level and explain kind of baseline what you're doing and kind of how this will all fit together?
Sure. I have a little presentation here. It's very 3 slides. So we tell all our instructors, no death by PowerPoint is allowed. So I will try not to violate that rule as well. But basically, we have a Raspberry Pi. It's about the size of a credit card, and it is a single board computer. And I think the great part about the Pi Foundation and what they started years ago and what they continue to do is build really high quality components and put together a really great system. And then you have on that top side, if you see up here in the corner here, that top side is actually like what they call the GPIO. And what it really allows you to do is interface with things in the outside world. And there's always been this like kind of mystery when you buy a product off the shelf, when you buy this stuff, like how this works. And when you get into it and you start writing code that reads from whether it's a temperature sensor or a moisture sensor, or these kind of things, when you start getting into like how it actually works, it just kind of unlocks like your brain, just like, oh man, that's amazing. Like I didn't realize it was that simple. And so that's really what I love about it. And I think, it's just gotten better and better over the years. The one we're using today is a Raspberry Pi 4B Plus. It's got 4 gigs of RAM. There is a Raspberry Pi shortage, a Pi shortage, as they call it right now. If you were to go buy one of these off Amazon at the moment, I think they're somewhere, the scalpers are at maybe $150 for whatever reason. So anyway, like I said, Catherine said at the beginning, we're going to give this away. Also, we have a RC522 RFIC card sensor module, which is basically an NFC card reader. It does a different band of frequencies that it can read, but I mean, the card reader itself is, maybe $7. So it's maybe $8, somewhere in that range. It's very inexpensive. And then we also are using the RFID or NFC S550 smart cards. We can use what's called like the N215, which is kind of like what Nintendo would use. And if you wanted to emulate amiibos, for example, and pretend you had those, or something like that. But for this example, we're just going to keep it simple and use an older S50 smart card. And also, we of course need a micro SD card that's going to store our operating system that we are going to put on the Pi. And I will say up front that I know, for example, we can use what's called, I keep clicking that tab. We can use what's called RetroPie, which is kind of a front end for emulation, and it kind of manages all the consoles and systems and everything like that. And this is probably the most popular one for the Pi and probably in the world actually right now. But I think given this tutorial and given where we're going, we're going to start with, we're just going to put it on a base install of Raspberry Pi OS using Raspbian. And I think we're actually going to use the Buster build, but we can get into that as we go through it. But hopefully that answered your question, Catherine.
Yeah, this is great. I'm super excited to see how all of this comes together. This is personally is my first time watching something like this in real time. So I'm super psyched.
Yeah. Don't worry. I've done a lot of praying before this. So it's very hard. Like, and I going through this, I give so much credit to the instructors that we have. Like, I cannot believe, like, because they are on command lines and doing stuff live in most of the courses, I would say. And the amount of things that you are when you're typing on camera, when you're trying to do stuff, it becomes, I don't know if it's anxiety, nerves, whatever it may be, but like it is 10 times harder than sitting all alone on a laptop doing stuff. And so I give them all the respect in the world for being able to do that.
Where would you say your anxiety level is now on a scale of 1 to 10?
I'm putting my hands on the keyboard in the home position, and no keys are being pressed, so we're not at a 10. So I would say not able to do surgery, but not at a 10. So somewhere in that range.
We can live with that.
That's for the software side, like we talked about. For the hardware side. For the software side, like I said, we're using Raspberry Pi OS. We're going to use the Raspberry Pi Imager. It's a very simple way to get the OS onto the memory card. You can use Etcher, you can use a bunch of different software to do that, but this is really just the easiest way to get our memory card initialized and ready to go. Then we're going to jump in and talk about how to use Python to leverage some of the libraries that are available to us to interface with the Pi. And then, of course, we're going to use RetroPie / Emulation Station to tap to play. Just want an overview of the steps. This is the agenda, and then I think this is the end of the slides. So we're going to just prepare the SD card, set up the OS. I did most of the setup for the OS already because it is time consuming, and there's probably nothing more boring than watching an OS install for the next 20 minutes. So I've done a lot of that. We're going to do the wiring of the module, and then we're going to do a little bit of Python scripting, and then we're going to talk a little bit before maybe after we play. Maybe this is after the play part. We're going to talk about how the giveaway of what the components you've seen here gets even better. So that's awesome. And then we're going to talk about kind of from a software standpoint, like what we could do to really make it kind of next level, almost commercial ready kind of thing. So that's the agenda. So let's, I think, like I said, end of the presentation there. So the first thing, just want to kind of go through and show this aspect of it. This is the Raspberry Pi imager. So we're going to choose an operating system here. And given that RetroPie right now is supporting the not Bullseye, but Buster, we got to select our OS here, and we can go for 64 or 32. Doesn't really matter as long as it's Bullseye. Buster, sorry. And so we'll just pick this one. We pick our storage device, which is this guy, and then we just click write, and then this will write to our memory card, and now we're kind of have the base. Okay, well, after we pass the permission check, this will write kind of the base operating system onto our storage device. This would be like installing Windows from a ISO onto another drive and booting it that way. So that's kind of step one as we get our SD card prepared. Very straightforward, very easy here. It's a few clicks. Now we're going to jump into the desk view. Move my water out of the way. Okay, and this is the Pi itself. Let me see if I can get this zoomed in. There we go. That's beautiful. And then you see we have our system on the chip. This is our processor. We have our memory, etc. And so this is the RFID reader. Very straightforward. Just a few wire headers off of it. Now these are the GPIO pins I was talking about earlier. You see that in the camera there. So we have to wire these wires to the right place on the GPIO pins. And fortunately, with this kit, just to make it a little bit easier, instead of reading all of these tiny things on the card, we have this little sleeve that just kind of slips over the GPIO. And then we have a kind of color code that kind of puts us on track to make sure we get the right wiring in place. So I'm just going to wire this up real quick. It's going to go orange to 8. Can you see that okay, Catherine?
Yep. Looks great.
It's easy, right?
So I have a question. So how do you know which wire goes to which number?
It's in the documentation that comes with the RFID reader. So if you look here, this is the kit that you get for $8 off Amazon. And you see, let me unzoom this a little bit. It gives you a cheat sheet. It says, hey, you have an lead color, I'm sorry, and so orange, and that goes into Raspberry Pi pin 8. Okay, and then on this card, you see there's an 8, and we have the orange. There we go. I don't know if I can unblur that a little bit, but it said there's an 8 there, and now we have the orange lead going into the 8. And so the same with the SCK11. We put the yellow pin, and then we go white, and that one is the MOSI 10, which it's hard to keep it in camera and while you do it, but we got it. And then this one to 9. So this is all like very paint by numbers so far, which I love to do as well in some free time. All right. We only have 3 more to wire up here. Let's just do that real quick. So it says blue goes to ground, gray goes to 25, and red goes to our 3.3 volts. So we'll put the red on the 3.3. We'll put blue to... Actually, in the picture, they show it... I'll show you in a second here. Let's see if I can... There we go. Then gray goes to 25. Okay. So now our GPIO pin is all wired up, and if you see, this is the manual. This is what it looks like in the picture as well. You see over here they have the red and the blue going to the top of the card at the ground and 3.3 volts up there. Actually, I want to put it here, and this is for what is coming later as part of that same giveaway. And we're going to need these pins here. And so instead of remapping the pins, which you can do in the software, I'll just leave them empty for now, and we can use them later. So then we're just going to plug this memory card in. And like I said, like this is not the memory card that we just formatted. It's the same operating system. Everything is the same. It's just now that we are, it's a little bit set up so we don't have to wait for the whole process. All right, now we're gonna plug our power in here, and then Catherine, this is where it gets dicey.
I'm waiting.
This is where OBS may complain at me here. Okay, now we're gonna plug our. This is these 2 ports here. See, with the Pi 3, which I have actually sitting right here, in a Pi 3, you had nice full HDMI, which was great. But now we have 2 of these micro HDMIs instead. And so now we have to get this cable, this tiny cable in here. And then we're running that into one of these really cheap, I would say really cheap HD. It's just it's an image, a video capture card that, I mean, this thing is probably $15 and it's maybe even less. But it runs that right out to type USB Type C. The cool thing about this, not just for this project, but in general for this cable, is that you can run an iPad directly into OBS, play games on your iPad on your computer, and leave your iPad in your bag or whatever it may be. It's if you know, or any system really. But super cheap, and using your computer as a screen or your thing as a screen is fun. All right, let me get this in here. Okay. Everything is like balanced, like I'm at a coffee shop here. It's perfect. All right, now let's go to the Pi. Hold on, let me power that down. Let's make sure everything. Oh, that wasn't plugged in all the way. We're good. They are very temperamental. Thanks for the comment on that. I forgot to mention. I forgot to mention. Yes. They are not like the expensive capture cards you can buy that usually just work every time. But they are very small. So that is a win in that column. Now we need a keyboard. Let me switch back. Sorry, you're just watching. I forgot to set up the mouse. Let's get that out of the way. We're just going to go full wired here for try to control as much as possible. Any issues? All right. We have power. What do you see, Catherine?
Well, I see a blank screen. Is that what I'm supposed to be seeing?
Yes. No, that is not. It's my USB. So I take it back. To anyone that said buy this USB thing because it's cheap. It's maybe. Let's see. It's not showing. And for good reason, it does help to plug it into the computer.
See, I was going to ask that.
No, that's it's usually a good thing to do. All right. think we're good. I should probably reboot it just to make 100% sure, but no, we're good. Abracadabra. That's right. I mean, at least the capture card is now showing up on OBS instead. Why don't we just make sure everything's plugged in? We're good.
We've got some good tips here in chat. Solid tips. Power
Solid
off, power
tips.
on.
Power. Yeah. When in doubt, reboot.
Hit it. Yeah.
I mean, I think it's gonna work. But I've been wrong. Hey, we have a blinking cursor. That's usually a good sign.
That's it's a good step.
I mean, yeah, there we go. It's gonna. So this should boot us right into Raspbian OS. Not RetroPie, but we'll see. Hey, there we go. Perfect. Okay. So we walked through setting up the NFC reader. Now we're going to walk through kind of the setup on the reader itself. I think is there is some steps here. Once you install your image on the card, now it's really about getting the libraries needed to talk to the reader itself. And so let me get this window is going to have to get a little zoomed in here. Can you see that okay?
Yeah, looks good. Yeah.
I can keep it. Okay, I can shrink it even more. Yeah, so what we're really looking for is it's called SPI Dev and MFRC 522, and I'll put this in the detailed instructions. I have them all written up for you, and I'll attach that. We'll try to figure out how to attach that to the video. But really, this is where you can just get in, and the first thing, we can load in the config, go to interface options, and we need to make sure that SPI here is turned on. And so we would go into here and make sure that interface is enabled, and then we would have to reboot our Pi. But like I said, like that, I've already done that, so we're good there. We don't have to reboot. Then we can finish our Raspberry config. You can also, I think, just in the interface over here as well, there's preferences and then Raspberry Pi configuration, and we can just double check over here interfaces. I just point that out to our Windows friends as well that may not like the terminal, but that is an option. Next, we want to just make sure that the SPI that SPI mod is loaded, and so in Linux you would type SPI mod. You would grep. If you guys don't know, this is the pipe command. So it's basically saying send the output of this grep command into ls mod, or vice versa rather. And as you can see, that is loaded. So now in any situation where you have kind of Linux, I would say, in most situations where you're loading new libraries, the first thing you really want to do is after you kind of set this up, you have the Pi restarted, is really kind of update. This is what I love, always do is, whoops. I forgot sudo apt update, and sudo apt upgrade. Once you run that command, it's going to go through all the packages on the system, look for updates, and then upgrade. And then the next command is going to basically upgrade all those packages that it found during the update command, which updates your local repositories. So this is kind of the first step in most instructions dealing with Linux, or especially on the Pi, is making sure you're at the latest to all the versions. And that helps when you're pulling in new libraries and packages, make sure that they're discoverable and available, so that you can do an apt install. After we do the upgrade, then, of course, we want to apt install Python 3. We can go dev and then Python 3 and then pip. So what that is installing Python, the development environment for Python, and then pip is a package installer for Python as well. So we want to get both of those installed. Then running through and pip 3. If you use Python 3, it's pip 3. If you use Python 2, it's pip. It's still, I think there's a diehard fan base of Python 2 that still exists. So I don't know if that's going to change for a while, but and then we want to install SPI dev, and then MFRC 522. Now that is the actual library for this card to read and write from the reader itself. So I will pause there for a second. Those are the steps that I went ahead and pre-did just to make sure, because some of those package loadings, everything like that, really does can take anywhere from 10 to 15 minutes to do. So I wanted to make sure to get kind of that stuff out of the way. So if everybody is cool there, then we can. The next step is really, I think at this point, kind of you would just reboot the Pi and then really set up emulation station. And like I said at the beginning, you could run this off a pure emulation station image, and get down into the command line and do all these things from there. But for this tutorial, walking through with a UI is much easier to demonstrate and everything like that. So like I said, we got Buster Pi installed, so we're gonna app install LSB release, and then let's see. So this basically, if I see Catherine, I'm only mistyping just a few words, so anxiety level is a little lower. So basically, we want to make sure that Git's installed, and we can run these, and you can see it's already, these two have already been installed, but that installs Git and LSB release. These are needed for RetroPie, which then we can clone down, and I'll make a directory here, git clone. We want to go one level deep, and then we want to, and these are all the instructions too for setting up RetroPie. You can find directly on their website that I had pulled up earlier. Are you confused yet, Catherine?
I am trying to follow along. I'm impressed by how well I'm following along, actually.
That's good. If I could type and spell. Oh, you know what actually helps, Catherine? You know what helps whenever you're installing packages? How do I get back to my desk? See, we didn't add this thing to Wi-Fi yet, and we have no internet at the moment. One thing that really helps is when you try to access the internet to have internet.
Internet would be
that actually helps.
It gets back to the plug it in.
It's key.
Is this thing on?
It is a key step. All right, so now we should. I mean, we can test connectivity. We can ping. We'll just ping like Google's DNS servers or something. Okay, good. We're getting somewhere. So now we have internet. So now we can clone RetroPie. And then we can go into the RetroPie setup, and then we do chmod +x. All that is, Catherine is saying, change the permissions of the file to make it executable. RetroPie setup.sh. And so we can change that, and then all we need to do now is just run that script. Setup.sh. Okay, and I would say this one takes probably around 5 minutes to run. As you saw by the boot screen that came in, I've already installed this, so to make it, just as seamless as possible, and try to avoid as many errors. But it's super straightforward, and I think it's very, getting those instructions and clicking. All you do once you run that script is just I can actually run it and show you without actually installing. That's a lot. Here we go. If I can get out of my command line there. Sorry, you have to run this as root. Yeah, so basically all we need to do here is just click basic install. It'll take about 5-10 minutes and run through everything. Install all the packages you need. And on top of that, it'll install all the emulators for all the systems that you might want to ever play. The Raspberry Pi 4 is pretty capable. I mean, it can play if you were playing consoles, it can play all the arcade games, NES, SNES, etc. I think like fairly well through Dreamcast. N64 is a little hit or miss, but I think it's pretty capable for what we're talking about here is like a credit card size computer. I mean, if you go back, like I said, if you look at my cabinet over there and see these massive devices that are, they're pretty big. I mean, I have a 3DO sitting right here. It's the old Panasonic 3DO. I mean, you can run this now on a Pi no problem. So pretty amazing how far technology has gotten. And don't ask why I have a random 3DO sitting there, but
I don't ever ask questions about what you have in your basement anymore, Richard. There's no telling what's all around you.
Okay, so thank you. It's all fun stuff, I assure you. So that next thing we have to do is we have to get some games onto the system. Unfortunately, due to I can't really tell people how to get games on their systems. Today we're going to be looking at SNES and NES. You can get attachments to the Pi that can actually back these games up into a file that the emulators can see. But you can also, this stuff is 30 years out of print. So, but anyway, we need to get games on our system, and I want to just set up the structure here. So I've already had in the two games that I have there. We have NES, we have Star Tropics for NES, which is the one I showed there, and then we have the Mario Kart there for the Super Nintendo. And now let's get into the fun part of using our what looks like right now. And I can admit that this does not look kid friendly in any way. It looks like it will fall apart with just a few touches. So we got to go from this into something that our kids want to reach out and just like play. And I think first off, we need to get the reader, everything kind of working on this. And so I think this is where we can jump right into some Python code. We're just going to use the built-in, the IDE here that's kind of built in. We create a new file, and then we're going to just bear with me a sec, Catherine. Okay, so first line, just telling the environment that we're going to be using. It's a Python 3 file. If I can type, it would be great. We're just going to import some libraries here. We're going to use the GPIO pins. We're going to use what we installed before, which is the MFRC522. We're going to import the simple version of that. That's all we need.
I love Elmal and 24's advice. Don't forget to blow on the games before you try to play them.
Yes, that is great advice. What I always found that worked for me was just, on the NES, they have that little finger tab to pull it out of. What always worked for me is rubbing it back and forth, just to get just that much grime right off the contacts.
Everybody had their own kind of like technique, right?
I think they did. All right, so we're just setting up our Python kind of environment here, that where we have kind of import commands to get to the libraries that we may need while doing this. The next is we got to initialize the reader, which is the simple MFRC522. So that one's good, and then we get into a try statement here. So what this is basically saying is like, hey, we're going to try to run this. We're going to try to execute this code. And then we're going to, if we fail on our try, we're going to run through our finally statement, which just kind of cleans up the GPIO pins. So, but what we're going to do is we're going to write some code that just puts us in a loop, and that's going to say while true, meaning like forever and ever. That's how you would read that, is that loop is just going to always run. And on these cards specifically, there's two spots. There is the ID of the card and then the text that is on the card. And so we want to just kind of, I think like when you're writing code like this, to me, it's really easier to just kind of write it in sections, kind of test along the way, and make sure that like the output you're getting is what you would expect. And so at this point, like that reader.read statement is going to sit there and really just wait until it gets input from the GPIO pins and from a card. So even if we were to stop here and run this, we should be able. I mean, obviously, if we print the ID, we should be able to see what the ID of our NFC card is. And then finally, GPIO. So we're just going to clean up the things. And Catherine, can you just debug this real quick and make sure that's right?
I'm already working on it over here.
Good. Okay, let's just oh, my face is covering up my new folder and others. Oh wait, we made this folder earlier. We might as well use this. Sorry, that's a little slow there. Okay, so now we should be able to jump down to our demo, back up a folder, Python 3, read.py. Now we just have a cursor sitting here, and that doesn't do us much good. But it is literally just the loop we wrote. While true, sit there and wait for input. So now this is the moment of truth, Catherine.
There we go.
Let's see if I can in real time here mess with OBS and get. Ryan would kill me right now, but let's see if we can get this on the screen as well. Oh, look at that. Oh wow.
Oh wow.
Yeah.
Now you're being an overachiever.
No, I don't know about that, but we now have some. Now we can see our pie. So now I can go down here and I can tap this to this. Oh, look at this. We got numbers. Oh, an auth error. Okay, that's good. Now we have the ID of our card. So this card, whenever I tap it, it's going to give me back this same ID here. So if I keep tapping it, you'll see get the same ID. So I would say this is where I start and go, okay, now I know like what this card ID is. I think this is where I start looking and saying, okay, well, maybe I'll just use the card ID, right? So we can say like if ID equals yeah, somebody's gonna yell at me that knows Python really well and say like, hey, it's 2 equals. I know, it's getting there. I used to teach Java, and I would say this, over the students' shoulders, and it was always they were like, yeah, I knew that. I was just waiting. So on the if side, we can do an if statement just like this, and now we can say if the ID equals this, then do something. What is my tab button is just not having it today. So I think what we want to do is this is where I think we really want to get into like the actual launching of a game using everything that we set up before. And I would say this is kind of the most basic way. And so we have to figure out like how do we launch a game from the command line? And it turns out that there are some command line functions, and if you can see the window here. If you see the window here, there are some command line functions for RetroPie and Emulation Station. And I've pulled up, let's see. Let me see if I can pull up a browser tab. let me pull this up. Sorry, Catherine. No,
This is great.
All right, so let's go back to the desktop for a sec. Okay, so if we look here in the RetroPie, we see like in the script modules, supplementary run command. So this is where I started when I was kind of just figuring out like, how does this work? How can I get like run a command that will initiate, everything needed to kind of set up and run, like select the console and all that kind of stuff, right? Like it's not just like run the command, you're good to go. It's like I needed a command that I could run that was like, you tap the card and let RetroPie handle the heavy lifting of like selecting the console and all that kind of stuff. Anyway, so the run command was what I found. And if you scroll down, we can, and this is super helpful regardless if you're doing this project or if you're doing any projects and this I think comes to the power of like open source, is that, you jump right into the documentation, not even documentation, you jump right into the source code and you look here and it says get params. Now we know get params means like, hey, I'm going to pass in something at the command line and I want to take in those parameters and do something with those parameters. And then we can come right here and we say like, if the command is sys, okay, or port, then argument 3 should be the system name, and argument 4 is actually the path to the ROM. And so we can kind of read through some of this code. I'm not saying it's all easy to read through, but some of it, and just kind of get the comments to say, okay, this looks like I'm on the right path. All I need to do is create a command function in Python that runs this command and passes in the system name and then the game name, or the path to the ROM file. Super helpful. So now I think this is where we can go back to our Python. Okay, it's so confusing where my mouse is. Okay, we go back to our Python code here, and we can now add that into our conditional. So now we have if ID is that, then we're going to do what we call output equals sub process.run. So that's going to tell this, we're going to run a sub process or fork a process within Linux. And if you look back at where that command is installed, it goes to actually, just so I don't typo anything, we should be able to just ls this. Actually, let's just cd in there. Make sure it exists. OPT, it's in RetroPie, supplementary, run command. I'm just hitting tab for like auto completion. Mm-hmm. LSAL. Okay, there's our run command.sh. So we can do a pwd, print working directory. We can copy. In 60 years, they have not perfected copying from the command line. Especially, if you're using PowerShell, it's like, do I just click? Is that a paste? Anyway. I don't want to go into that.
Different shortcuts for everything.
Let's see now. Let's paste this in. So run command and then run command .sh. All right. Now our first, and this goes back to our first parameter, and I think that was based on the mode from the documentation that is showed over in GitHub. So we know the first parameter is going to be 0, setting the mode, and then we have this sys, and then we need the game. So we'll try NES, and then a path to that game. And so we can go back over here, cd games NES ROMs, NES. And we know, I don't know if we know, but like the NES file is actually the actual ROM. So now we do pwd. Catherine, this is step one. This gets better. This is why we iterate.
I'm fascinated. I'm glued to this.
But if you were, I just want to kind of demonstrate here that if you were going to do this for everyone, and this I think, I keep grabbing the wrong mouse on my desk too. So there's a NES star. If anybody hasn't played Star Tropics, it was not popular at the time. It's very popular now, but just it's a good game. Okay, so there we go. Now we have our NES, and then we should put over here while we're saying while true before we read. We should really tell the user what to do. So we're just going to print here. Hold card near reader. Okay. Now, if everything is right, which may or may not be, we should be able to run this. Maybe I should check the comments first to see. Okay, hold card. All right, so we got our card. And we're going to hit the reader. Oh, no. What am I? Light over here. Okay. It's fine. Catherine, can you just debug that?
Yep, working on it.
Like if you come to the end here, no such file, RetroPie run command, despite me copying and pasting it in, and I don't know. I think I typed that correctly. I mean, I literally pasted it, so it can't be not wrong.
I'm seeing some sympathy, some familiar sympathy coming in from the comments there.
you try to
3 M's.
Oh, was that it?
That's what
you were correct.
Brian Hu was saying. 3 M's.
Thank you. Yeah, see, that's super helpful.
There you go.
I told you this keyboard actually has more sensitive keys, so maybe the anxiety level is actually pressing keys here.
I think that was good though. See, we get to see what happened. We get to see your thought process. Go back, take a look.
Go back,
repaste.
Okay.
As long as everyone has 300 people watching them do everything, they should be able to fix it.
All right, so I tapped it, and it launched the game. So now everything's good, right? We launched the game, we tapped it, and we're done. So now all we have to do is for every card, all we need to do for every card now is to find the ID and then paste the ID into the reader and have just the most awful if statements ever known to man. That's one option, and I wanted to show like that is an option. Like I think it's well, we know it's not a great option, and we know that, but it's also a way to like just get the functionality you want in place, and then work back to like refine the code. Because I think a lot of times, like especially I know me when I'm like writing code in the evenings, like I want to like Catherine, remember like when you would first go to like elementary school. And your parents would get you some new binders and everything, and you're like, "Man, I'm gonna set this all up and make this amazing." And then the fourth day of school comes, and then those things are just trashed in a backpack. Those 5 stuff on the side, half of them ripped off. I mean, it's like, why did I spend all this effort up front to make it look amazing? And like, I just now I don't have like a way to keep it going. Anyway, it's the same thing here. Like, what I like to do is just get like the base functionality. Now, like we go back and we apply some software principles about reuse, about, all these kind of things, right? And so I would say like, this is where you get in that situation where you're like, okay, I can read a card, start a game. Great. Now all I have to do, and you can see my camera here in the bottom left, This is just an example. Now I can take that card. I can print a nice. You should have told me it was backwards the whole time. A nice label on it, and so that way when I play, I know that this ID is now associated with this game. Okay. Obviously, when we went out and got our best $8 card reader, we assumed it would have write functionality. You know what I mean? We assumed that we could write something to this card and not just use the ID on it. And so what I'm going to do is I'm going to go over here. Where's my window? I'm gonna copy this. I'm gonna copy read, and I'm gonna make one called write. Okay, so we're just gonna copy what we wrote for read and make it into write. Now I should be able to come over here and open up write.py. What do you know? It's the exact same thing as the read.py because we just wrote. So next, what we're gonna do is instead of this try statement and instead of this while true, what we want to do is just write something onto this card. Okay. I actually, can we go back to this read just for a second and let's get rid of this guy. Let's get rid of this. We don't need that right now. Let's just back up. Let's print the text. Okay. Let's see what the text is. Okay, hold the card near the reader. So it should print an ID and then a text. Okay, what do you know? There is nothing on this card. It's completely blank. That's why you're seeing a blank line. So now let's go to write. Okay, and let's get rid of this guy because we're just writing to the card. Okay, and we have reader.read, but we obviously don't need that. So next what we're going to do is we're going to get input from the user. So we're going to say, we're going to call it the same thing so we don't get confused. Our text equals the input, and we'll call this path. Told you, everything's just barely teetering.
Okay over there.
Yeah, everything's good. Everything's good.
Was that your XML?
I don't know. No, that was a light. Okay, so what we're gonna do is we're gonna get the path to game. We'll say relative game path. Okay. So now let's fix these. So it's readable there. Okay, so now we have we're going to ask for some input from the user. We're going to say, hey, we want to get the game path, and then we want to say that now we want to give them some instructions. So let's say like, hey, place tag near reader. That sounds like it makes sense. And then we're going to just do a reader.write. We're going to write that text to the card. And then we're going to be like, we're going to say print success fully written. And then finally, we're going to clean up our GPIO bits because we like things tidy. Okay, so so far things have gone okay. We haven't run into major issues. But now, let's try to write something to this card. Okay, relative game path. We're going to say NES. What was it? NES / Star Tropics. Place tag near reader. Here we go. Where's my tag? If you can see in the bottom left screen again, we're going to tap that. Okay. All right. Well, don't worry yet. I know we got some errors there, but it's okay. We're gonna read. We're gonna read it now and see what happens. We didn't write our text. All right. Let's try this again. Sometimes it's not just the USB-C video capture cards that are finicky. It could be. This is where when you start typing these things in multiple times, you're like, hey, I wish I had a clipboard. What's going on here? Let me make sure I'm using the right card. Last index out of range. Okay. If anybody wants to tell me why it's broken,
I was gonna say let's hear from the viewers.
reader, no, the code is flawless. That's how I'm sticking to it. The code is flawless. There we go. Okay, so look, see this card? I'm throwing it away. I'm not sure where that came from. There's 2,300 of them on my desk. So, okay, so now we have our. Now let's. Before we celebrate a little too early, why don't we run our read command? And now let's read the card. Oh, there we go. So now we have in the card, on the card itself. Now we have the ID, and now we have the path that we set when we did the input. Does that make sense? So we wrote to the card what we typed in. Now every time we touch this card, we're going to see that. Let me give some space here. We're going to see that we have now the ID and the path, which is that's helpful because now what we can do is we can go back to our read function and we can really start doing some probably better Python code. I'm not going to say great, but we can do better Python code. Because now we know that the text coming in from this read command is going to be a path that we can now, like the path to the file. I would say relative path. So what we can do now is we can say like, hey, my ROM is equal to the path. I mean, that's from pathlib when we're importing path up in the top of the file. And so we now want to we know our base directory is the home, py, games, ROMs. And now we want to concatenate. We'll do text.strip. And so what does that do? That takes the text that we took in from the reader and strips the white space off the text just in case there's extra padding. Sometimes there's spaces, especially on the reader side. And so we want to strip that white space off and just append that to the path, to the relative base path. So now we know ROMs / NES star tropics, and we saw that over here in our directory structure when we initially kind of set this up. So now we have ROMs, NES, star tropics. So we kind of see this matches those games are in that folder. I would say now we have the ROM path, but I don't want to. Every time you scan a game, or you scan a random card, you don't want your system just to crash and be sitting there waiting for you to restart it. So this is where I think it's very important to kind of just put a little check in here that says if my ROM. We can use the is file. So that is using that same library on the path library, and there's a is exist and is file. So we want to make sure that, sometimes what if you entered in something incorrectly when you were doing the write and then you try to run it, it's going to crash everything. So we want to make sure that it is a file before we try to execute something. And I'm glad I deleted all of my sub-process command that I messed up before. This is where I'm excited when I delete something by accident. Okay, the next thing we need to do is, because we saw that path command, I think people will remember it, but I'm not entirely sure. And I accidentally, I should not have deleted that. I should just comment it out. Let's rewrite the sub-process command real quick so we know what it looks like here. Subprocess.run, and we're going to run opt. Is this still in my paste history? Yes.
It's the little.
I mean, sometimes it's the little wins in life, Sometimes it's the little ones. We're gonna say it's a system, and then yes, and then we have. Okay, well, let's just leave it like that for a second. Okay, so if it exists, then we're going to say, hey, it's NES, run the game. But how do we know where to get this, right? This NES. And how do we know just to get the game? Because we know that the path is all set. Well, we have the path, so we can definitely just use this instead of game. We can just say my ROM. That's going to basically inject this path, this relative base path, plus the string that we have written on the card. But next, we got to get this system. And so this is where I think it really comes in handy to do some. There's a lot of ways we can do it. I'm just going to do a text.split because I know that it's going to have the forward slash. It's not great because then your entire structure has to be always system /. But it's okay as long as we know that. I will just go with that. So we can just double check to make sure that works. Loading system plus ROM. So this ends up being an array, so we can just get to the first index of the array, which is at key 0. So the arrays go from 0, 1, 2, 3, etc. And so at 0 should be the word NES that we set on this card. And then we want to with game plus ROM. So 1. How are we doing on time?
We're good. We're good.
Excellent. Okay, so now we should be able to print that out, and then let's just should we just maybe before we get too far ahead of our skis, or however they say that. I live in the South mainly, so skiing was not really a thing you did often. All right, and so now let's cancel that. Let's run read again. Let's hold our card near the reader. Okay, so loading system NES with game start drop set NES. So it's perfect, right? That's exactly what the expectation was from that subprocess run command.sh. And so now we can basically go back here. Let's get rid of this. Now instead of NES, we're going to say ROM sub 0. And because we're looking for a full path here, we can just leave this as my ROM. There's no need to use the split of the ROM of 1. Maybe if you had a different pathing structure or whatever, we could use that. But anyway, so now we're going to. All right, I figured out what it is. If I else, we're going to just say prints unable. And then maybe it's just some debugging here, like my ROM. All right, Catherine, how does that look?
Looks good to me.
Let's do it. Let's run it. All right, so now, if all that works, we should now be able to hold the reader next to the card. Oh, it's launching.
Wow.
There it goes. Yeah, and you can also configure that splash screen to not show up and get right into the game. Okay, so and now we hit escape or whatever hotkey button we set up within RetroPie. We can set up hotkeys with a controller, so we can hit select start at the same time as the most common one, which would drop us back down to the hold reader screen. And then basically now we start seeing, hey, we can create an entire library of physical cards that then we could put out. Have very interactive for kids. I find it like sometimes ROM libraries can get very very large, and so finding the game you want to play, etc., becomes more of a chore. And sometimes you just want to jump into a game of Tetris and just really quickly. So that's kind of the how we can do all of that in such a small package. And I think normally when Raspberry Pis are $35, $45. $8 for a reader, it's probably the most capable system you can buy for sub $50, especially on the new side. So the next thing I think we should do here is just make sure that we are not not getting too far ahead of ourselves, and let's try one more game here. We will try to run Python 3, write.py, and SNES.
Nice choice.
And so we can go over here, and we should go to SNES. And, it's super okay. And just make sure that we have that. All right, let's just use this card again. Oh no, wait. Oh. It is my fault.
So what's going on?
It's just it's just like, I think what happens on these readers specifically is that if you don't really hold and make contact, and you do a half contact like that, you basically it's reading off a file stream, like just a stream buffer, and if you're pulling it off while it's reading the buffer, it's just like that split second. And so I think, like, once I think just holding it to it, as you see, like, it just works. I think it's just my anxiety shaking my hand too far away from it. Anyway, that's my guess. But if we go back to now, we should be able to run Python 3 read. We should be able to tap this card. All right, so we can see it's loading up SNEX9X, which is the emulator for the game. Oh, that looks all too familiar.
Having flashbacks.
So there we go. Now we have Super Mario Kart nicely working. And so I wanted to show this. If I can get back to this is what fell a little light here. Okay, there we go. We have some light. Stay. All right, so thanks. That light lasted 8 seconds. If we look here, what I went and did is I've printed off just some. You can get some like Avery labels. They're pretty cheap for just some clear labels that you can inkjet print on, and basically create the cartridge so it looks just like an authentic. It looks like the real thing. Actually, it looks like a TurboGrafx 16 game card. But anyway, I don't know if you know what those look like, but they're very similar to this. They have chips at the end. But anyway, so I think that gives us now a really great place to start. And here's the Super Mario Kart, and so we can see we have scaled this down quite dramatically. And no, there's no actual game on the card itself, right? The card is really used as a lookup to games that you do have, and I think that's there are many ways we could do this. We could do loops. We could sit there and go through a library of games, and then for everyone say, hey, hold your card at the reader. There's a ton of different ways to kind of expand upon this. But Catherine, the most important way to expand upon it is looks. You know what I mean? Because look at this thing. There's, you put this in a picture of a giveaway, Catherine, and I don't know. I mean, you probably have the 8 other people that own the same Debian shirt as me signing up for that giveaway. So what we're going to do as part of the giveaway is we are going to make this look so much better. So how do I get back to my desk here? Okay, so is that a better picture? We're going to power that off. We're going to unplug all of this. Not all of it, but all of these things. And we have this guy. Can you see this?
Yep.
Well, let me put it together first, and then does this?
I see where we're going here. I see.
You see where I'm going? I'm just very clumsily doing it. This is, like I said, I could not be a surgeon. Okay, so this is our NES Retro Pi case, and this is one of the nicer cases that you can have for the Pi. And the main reason for that, and you're gonna love this, Catherine. You're absolutely gonna love this. Look at this. This cartridge opens up. What is that? It's a game.
Awesome.
It's a little bitty game card. And not only that, if you look down, I don't know if I can get a good picture of this because the light that I had is now dead. But you see that right there? That is a connection point. So this game card, you can run an SSD hard drive, snap it into here, and then you plug it in, and now your hard drive is the cartridge. So really cool. So we're given that. That's part of the giveaway. Some lucky winner will get that. Now we just need to put our pie in here and make it look like something we could give to somebody and not feel kind of embarrassed about it. Although I would personally like it like this. I do love the case. So we're going to flip this around. And this is where the art of either soldering or what is the word? Finagling? Is that a word?
Finagling.
Yeah, we can finagle it in. And going back, the other beautiful thing about this, Catherine, is like normally on a Pi, you have no working on-off switch. There's no on-off switch on the board. There's nothing, right? But with this, we now have power buttons and a reset button that works, and our USB ports are now here. Okay, so I know I'll take that gasp as you're loving that. So we just need to wire.
I am loving that. Yes.
So we just need to wire up our case here. Here it snaps in. All right, here we go. This is where the fine art of finagling comes in play. We just slide it in. I'm sorry if I break this. You're going to have a broken giveaway. Okay, we're good. Good. I think just... And I won't torture everyone through the process of me screwing it all in. That light does not like to stick.
Was that the light again?
Again, yes. All right, we're just... See. All right. There we go. This is... We're just making sure everything fits, okay? We're just fitting it first. This USB cable over here, that's a bit cumbersome. Hold on. All right, so getting all this stuff out of the way. Can you see this? Is that okay?
Yeah.
Now, hold your breath. Oh! Perfect. Yeah, don't worry. Before I ship it, or hand it to someone to ship, I will make sure that it's all screwed together. Okay, now we got our USB cables coming in here. And in the back here now is where we put our it's on the side. Micro SD card, and actually it just goes in a little bit upside down. Hopefully yes, went right in. That's a good sign. That means the actual system's there. What am I missing? Power supply. Let's put the power supply in. Okay, just kidding. That's our monitor. Here and then power cable. The other thing too is it's a nice. It extends out the Cat 5 port as well.
So how do you actually control the game? How do you where are the controllers?
Well, now that everything's set, that's a great question. That's a great question. If only we had some controllers. Okay. Yes, part of the giveaway are these SNES controllers as well that we would plug right in. I didn't want to open them up because some people, we still have some pandemic stuff going on, but I didn't want to open it up and play with them and everything, but they're brand new. So we just plug these USB ports into here, and everything will just work seamlessly with it. And so we can hit start, select, just like we're playing Super Nintendo. We can also... I don't know where that went, but we can also do, we can use, it has Bluetooth built in, so we can use our Xbox controllers, our PlayStation controllers. We can use all of that as well, just over Bluetooth. And so we can just kind of sync them up, and it works right out of the box. They're all recognized as X input, so really awesome there. But yeah, now I think we have a fully functional, and maybe I spoke too soon again. There we go. I forgot. I have a toggle switch on the power supply itself. So yes, now we have one that lights up, and we can reset it, everything from the box itself. And so what I was thinking, and you can tell me here, is I was thinking taking this cartridge out, and you would just take your game cartridge and kind of just have now the reader is right here under this piece of plastic, and just tapping that to play your game. And then if you needed your hard drive in or whatever, you plug it in. But I think super cool, super cute. I think the kids will love it. I think it's like we said at the beginning, giving it all of this away. Well, not my keyboards and stuff, but all of the system and everything we kind of went through today, we're giving that away, putting it in a box, sending it to you. I will say there are other, if you're really interested in this stuff, there are a lot of other projects. There are a lot of cool stuff you can do with not just GPIO pens, not just RetroArch. I mean, you can also build the same thing. And this is my daily driver. It's reminiscent of an old Game Boy. It's also running Emulation Station and everything like that. So, I think that's it. I think the next thing, just to kind of review, is what on the code side and everything like that, is what would how do you really take this and make it to the next level, and to really make it more dynamic, I guess, is what that's kind of I think the next step would be, trying to get that to a place of being a little bit more dynamic and a little more, so you're not having to kind of write every card and type something in, but maybe going through a listing, or if anybody has any ideas of how to kind of make that a little less cumbersome on the initial setup. I know you're creating printouts and you're doing a lot, so like it's not a huge deal, and the whole point is to get a smaller library than a mass amount. But if anybody has any suggestions, would love to hear those as well. Or if there's any questions, we can take a minute and take some questions.
Yeah, absolutely. I'm watching chat right now, and I just I love these comments coming in. Like, first of all, a lot of people just saying thank you, Richard, for doing this, just for sitting down and kind of spending some time going through this, and sharing some really, really relevant and real world stuff, that people are doing. And just a lot of, a lot of excitement about the actual technical skills that you're able to apply here. It's very cool.
I think like there's, and I saw this a lot. Like I said, when I was teaching back at Auburn, like it's like there's like this big mystery box around a lot of these things. And I think once you get into like the details, and once you just kind of walk through it, I think, I just saw that comment pop up. But I think like just demystifying it and getting it down to kind of the fundamentals, it's really super straightforward. I mean, you see like how many lines of code? I think Ryan could tell you 13 is the answer of how many lines of code it takes to get it going and running a game, and just having like a really cool project. And I think also like when you see something, when you see something like this, and I will get back to this because this is where I draw passion from, is like projects like this. When you see projects like this and you go, that's cool, but I want to do it for gaming, or I want to do it for something else, or I want to do that. And like just being able to kind of figure out how to apply kind of the things to make it happen and make it real. I think that's what's super cool about technology. I think that's what's super cool about programming in general, is being able to kind of build this stuff. And what I love about like the Raspberry Pi, used to be, I will say, a super affordable option when they weren't being scalped. But I would say like that's what I really love. Is like, I was trying to grow zucchini. The prepper in me was trying to grow zucchini in my basement, and I wrote all this code in Python and Arduino with moisture sensors and all that kind of stuff, and being able to kind of create a watering system, with very few. I mean, it wasn't a crazy amount of code, but I think like it was just really cool to be able to have that, like take that on and just try to like just engineer your way through it. I think that's just challenging, fun part. And I think like I just want to get more people excited about that kind of stuff, and more people just trying, because even if you fail, you've learned so much. The failure, while it grew, it did not work out.
Oh, it did not work out. Well, maybe next time.
Transplant it. I mean, it's a process. I respect that. Once the tech side was done, I was like, it's working. I'm good.
Right. Yes. Failure is a part of the process too. It's all part of the learning process, right?
Yeah. I mean, just the failure of getting to this show was part of the learning process. I just
I see. Next time we'll be so ready for this.
yeah.
Now you have to start thinking about what you're doing next time.
Yeah, I know. And I was going to ask, I think the bearded IT guy. I mean, like, he's seen a lot of these shows as well, and it was like getting back to, we had the GitHub jam session. We had like just doing some fun stuff with Python. I'd love to see like from comments or whoever, if it's on YouTube, just kind of where you guys would like to see us focus more some of these live shows. We're here to have fun and really try to teach something in a fun way that like becomes, really trying to drive some of these walls to education down. So if there's anything that we can deliver, please let us know.
Awesome. Yeah, we are big believers in feedback here. If you are familiar with us at all, you know that we listen to it. Richard, you read just about every bit of feedback that we get. So we're always looking for ways to improve, get better, and deliver the very best product and the best return on your investment. I like your new nickname here, Farmer Richard. That's good. That one's gonna stick. That one might stick. All right, let's get to the giveaway. You want to get to the giveaway?
I will say, I know that there were people here last time, and I will say the shirts are going out this week. I apologize. I was at Black Hat, and I did not have time to get the shirts out. I will get them out, and all the prizes will be going out this week. So bear with me. I apologize. Black Hat was amazing, as you know, Catherine.
Yes.
And so anyway, now let's give it away.
All right, I see John Galliano in here in the chat. I met him at Black Hat, so it's nice to see you. Not the fashion designer, by the way, the other John Galliano. All right, we're going to do this. All right, bear with me while I run a randomizer. And I'm not going to share my screen because I don't want to share everyone's email address. So, but trust me, it is random, and the winner is Jose Soto. Oops, Ryan, I forgot to send that to you. I'm going to call out the winner now.
Ryan, she's going to call out the
winner.
winner.
Sorry about that. The winner is Jose Soto, an information security analyst.
Well, let's not
in the banking industry.
Let's be a little,
So congratulations, Jose.
Yes, that is awesome. Super excited. I will have this packed up and shipped to you. And if you need any help or assistance or can't get something working, or if anything happens, please email me directly and I will help you get anything set up that I can. I will send you I'll send you a pack of cards, all the things that you need kind of get going to recreate this. And obviously the controllers, there's heat sinks. If you decide to overclock your Pi, there's heat sinks. Everything's in the box for you. Whatever you could need is going to be there. Power supply, everything. So it's a full setup.
Awesome.
And,
we are
congratulations.
Yeah, and thanks for joining us, Jose. We are going to reach out to you with at the email address that you left us on the form, and we'll get that shipped out to you ASAP. Awesome. Well, thanks, Richard. This is very cool. Somebody looks like they want your shirt.
It's a little sweatier than normal, so probably I'll keep the shirt.
Hey, Rich, you made it through it. That was a big step.
That's a big step, I'm feeling less anxiety now. I mean, magically.
Someone suggested that maybe you should try giving your light away on the next show. Maybe just get that thing out.
Yeah, I'm going to give that one back to Ryan, who gave me that light. Ryan. I'm not going to product place any of these lights because they're
no.
They fall.
We're going to find something worth product placing on our next stream. All right. Thank you, Richard. Thank you, everyone who joined in. This was awesome. This was a lot of fun. People already saying they're going to bookmark it and watch it over and over again. And we're going to continue doing these really fun streams and more giveaways and have Richard on here a lot more. So thanks to everyone for tuning in. Richard, thank you. This is awesome.
Thank you.
And that is going to wrap it up for us. Thanks again for watching. If you missed it live, of course, look for the replay across our social media channels as well as on the INE website, where I should be live again tomorrow at 11:30 a.m. Eastern for another great stream. We've got Brian McGann, Rohit Pardesani, and former INEer Mark Snow, the band back together again. We've got them right here on INE Live. That's tomorrow at 11:30 a.m. Eastern time. Be sure to like and subscribe on the social media platform you're using so you can stay in the loop when we do go live, and of course, when we have these awesome giveaways. We'll see you next time. Until then, have a great week.